Hi, I'm John Paulraj, and this is part 7 of the complete solution series for IB Math AI HL Paper 1 Time Zone 1. Let's roll. We are going to dive straight into question number 7, which is the next question. Conrad is investigating the motion of a particle. The velocity of the particle in meters per second is given by this equation for the velocity. Vt is 2 cos t plus sine 2t minus 0.2. Be very careful. This is a calculator question. And where t is the time in seconds after the investigation begins. So he's investigating the motion of the particle, and t is the time in seconds after that investigation begins, basically. What do they have here? The y-axis, of course, is the velocity axis with meters per second, as they've labeled here. And the x-axis is in seconds. On the axes, sketch the graph of Vt for those values of t, for t between 0 and 6. Now, a couple of things, okay? Whenever you see this word sketch, in the IB terminology, it literally means show all details. I'm going to write that word down here, okay? Show all details, even if they've not mentioned. The moment you see that word sketch, while I'm at it, I think what I should do is also maybe show something from the instructions for any paper, okay? That word sketch in the IB terminology literally means show all the details that you can see on your graph. Because you know what, you'll just look at your graphing calculator, and I'm looking here because this monitor out here has my graphing calculator. So you'll see the graph, but then show all the details, max, min, intercepts, whatever, even if they've not asked, okay? Just, nobody's going to complain that, why did you show so much, okay? Because, that's the marks, right? This is like almost 2.5 marks would be allotted for that. So just to be able to sketch, what you see from the calculator onto the paper, you shouldn't be losing points on a sketch, please. All right, if you're an AI student, please don't lose marks on the sketching, because you're just copying a graph straight up from your calculator onto the graph paper. Label with coordinates. It says label with coordinates, part 2. It says the points where the particle has 0 acceleration. So we'll come to that later, but the first part is just to sketch. So I will first enter into the calculator, and then I'll come to this graph. Okay, so I'm going to switch to my calculator screen. There you go. And this is problem number 6 on my calculator. So we are going to insert a new problem like we've done before. And I'm going to call it, we need a graph page this time, right? So this is 7.1. So, problem 7 and page 1, which is the graph page. And on this graph page, remember the calculator is only going to, you can only enter in terms of x and y. Those are some limitations. Okay, so I'm going to enter the velocity in terms of x. So I'm going to write down 2 cos x. Okay, so 2 times cos of x plus sine of, I think I made a mistake. You can see the brackets. Okay, it's a good thing. Everything that I do, even the errors that I create, it's a good thing. So you can see that it can happen to all of us, okay? Especially when you're entering things into the calculator. Sine of 2x, all right? Sine of 2x, and then outside that bracket, minus 0.2. Okay, careful on this part before I put that, because sometimes we just enter and then we forget that. Why did I get a different graph? Why did I get a different graph? Your units when you're graphing, 95% of the time, we'll have to check that way to verify this, okay? 95% of the time it has to be in radians. It must be in radians, okay? So I'm just going to flip it to radians. Oops, everything went off when I flipped it to radians. I thought it wouldn't go. Okay, never mind. I will do it again. So 2 cos, I think some of you probably are just having fun watching me making all these errors, plus sine. At least, you know what? With my error now you can see, and I've made several, okay? I think I'd better stop talking while I'm writing or trying to use the calculator. Sine of 2x, and then there's a minus 0.2. Now that today I made several errors while talking and trying to enter the calculator, so be very careful, okay? This is something that, happens to me. Sometimes I say I'm not good at multitasking, but I think when you enter the calculator, be doubly careful, because, you're just going to, copy down the graph. So what you enter should be equally important. and there's my graph. Now this graph is vague, right? It's got like for all values, because you know what, when you come back to your question, you come back to the question, it says you are supposed to graph for values between 0 and 6. Okay, this is equally important. That means do not sketch any part of the graph that is before 0. Do not sketch any part of the graph after 6. Okay, this is equally important. And if you just enter the graph as it is, it's going to show you values before and after. As you can see, look, you can see the graph before 0. That's the graph before 0. And somewhere there's 6. I think if this is 1, 2, 3, 4, 5, 6. So if you're okay to graph only that region by looking at it, if you're okay to just by looking at it, okay, so this is 1, 2, 3, 4, 5, 6. After this, you should not graph. After this, you should not graph. And before this, you should not graph. So I'm going to try it on my calculator. I'm going to try to sketch it, but I'm also going to show you how to get only for that region. Let me just show you that part first, okay? Let me just show you how to do that part. So if I just arrow up and bring my function back, let me focus what I enter, okay? So what I'm going to do is that I'm just going to hit this key. The condition key is here, the control equal to, okay, just put that condition here, okay, that line, almost like that, such that line, okay, here, and here I'll put down the condition being the values of t. Here they say t, we are going to enter it as x, okay, because that's my independent variable. So the condition is 0 less than equal to, again go back to that conditions thing, all right, here, less than or equal to x, less than or equal to again, and what is that value? 6. So now when I hit enter, I will get only for that. Okay, this is like restricting the domain just to that. Okay, because you see on the calculator, on the question, they said for that section only. So if you're comfortable, like I said, if you're comfortable just copying down the graph as it is, you know, before 6 you should not graph, and after before 0 you should not graph, and after 6 you should not graph, that's okay. But if you want to know how to sketch the graph, how to instruct the calculator to sketch only for that section, then that's the syntax that I've showed you. I'm going to hit enter, and you can see just like that, you're going to get the graph of, you know, just that part. So let me just carefully do that, okay? And it doesn't have to be artistic, just note down the key points where it's going up, you know, that minimum, the maximum there, where is it cutting, okay? Estimate it, okay? So somewhere around, if this is 1 and if that's 2, and somewhere between 2.5 you're approaching a maxima, and somewhere between 1 and 2 on the x-axis or the t-axis, there's an x-intercept, there's a minima occurring between 2 and 3, and there's like a horizontal tangent again, you know, an inflection point literally around, what is that value? 1, 2, 3, 4, 5. So you just estimate that, and then, you know, somewhere there's an intercept. Just estimate, okay? It has to be approximate, but the shape has to be more or less as much as you can see. Doesn't have to be accurate, so I'm just going to sketch this as clearly as I can, okay? So I'll just mark the key points first, so you can see what I'm doing. Between 1 and 2, this maxima, between 1 and 2, this maxima, somewhere in the middle, right in the middle. So I'm just going to mark here, okay? There's a maximum here, and then here. Now, these points of reference give me the idea, you know, how to connect the dots then, okay? And then, what do we have? Where is the minimum here? This is -1, -2, and somewhere just before -3. -1, -2, just before -3. And this is between 2 and 3, I believe, yeah, between 2 and 3. Between 2 and 3, just before that, there's a turning point here, okay? And what do I have? And then the graph turns around, and there's a flat, as I said, that inflection point kind of a thing between almost like a -0.5 on the y, and on the x it is 1, 2, 3, 4, between 4 and 5. 1, 2, 3, 4 and 5, between 4 and 5. Okay, between 4 and 5, and negative somewhere on that side, okay? Somewhere there is like a flat, okay? If you want, you can quickly see that, okay? What I mean by that, okay? So along the x-axis, it's 1, 2, 3, between 4 and 5, and the y, it's almost like negative, okay? It's below. And then it cuts. The second intercept, x-intercept, for that region alone is at 5 and 6, between 5 and 6, okay? Just on this side of the left-hand side. Check again, 1, 2, 3, 4, 5, 6, okay? So between 5 and 6, 1, 2, 3, 4, 5, and 6, between 5 and 6. So let me come back to this, and I can just say somewhere between 5 and 6 there is, okay? Now let me just brave myself and do this graph. So you have this reference, and remember it's starting somewhere just on here. So maybe even that reference point I can draw here. Okay. So let's just sketch the graph now. So you have the shape a bit like that, somewhere down, and coming down nice and smooth, and turning around and turning around to flatten around this point, and getting here. Should I put the endpoint? What's the endpoint? It's above 1, just above 1, and at 6, right? Is it at 6? 1 minute. Let me just check. So this is 1, 2, 3, 4, 5, 6. Yeah. And so let's use the same color. Just above 1. Yeah. Just above 1. Just a little bit there. Okay. So this graph, I will just connect it here. Okay. It sort of doesn't, it's not quite like that. Okay. Just compare, just compare. It's not super artistic, but that's okay. That's okay. But what's more important, remember I said sketch does not mean just make a sketch like that. It means show all the details, okay? So what I'm going to do is that all the details that I can find in the calculator, okay, I'm just going to jump back to the calculator. So let's just go to the menu, analyze the graph, and find the zeros first. Okay, so there's a intercept here, and you can get that value. I'm going to just note it down quickly. Let me just check the settings. This is the document settings. Okay, so maybe I'll just come to the not the menu. Is it the menu? Yeah, I think it's a menu settings here. Okay, this is referring to the settings here. So here you can change it 3SF, and there you go. Now you get it as 5.32. So the moment I get that value, I'll just make a note here. Okay, so here I can write it as 5.32, 0 for this value. And what else do I have on the calculator? Go to menu, analyze graph, and do I have a maximum value here? Let's get that maximum value. Okay, you can get that there. In the same way, let's do the minimum value. Analyze graph, minimum, and boys and girls, if you're watching this video, it takes time to enter. Okay, so practice. Don't just skim through answers. Don't just read answers. Don't just watch YouTube videos. Okay, pause the video, try it on your own, because it takes time. Sometimes when you just watch a video or look at solutions, you have access to marking schemes and all those things. It's not just watching and reading. Okay, just make sure that you're trying it out, because even using a calculator, it takes time to put on those things. There's another intercept here. Okay, I'm just going to find that thing quickly. Analyze graph. There's a 0 there. And there you go. All right, so that's 1.52. Let me just write down all these details quickly. Okay, so I am on my iPad now, and so what do I have here? I have 0.524. Let me write it down. 0.524 comma, was it 2.4? And I have 1.52, 1.52 comma 0, and this is a 2.62, 2.62 comma negative 2.8, and I didn't find for that one. That's okay. I think these values are good enough. Sketch the graph, and we've done. So couple of things. Okay, the shape should be more or less the same. Show as many details as you can, and this is most important. Whatever interval they've given, do not exceed it, and nothing, only for those values. Only for those values. They may dock off points, huh? If you read your marking schemes, don't just look for answers. If you look at how the marks are allotted, they will dock off points if you sketch something extra. All right, label with coordinates the points where the particle has zero acceleration. Zero acceleration. Now this is the graph of velocity, right? This is the graph of the velocity. The acceleration is the slope. Okay, it's the derivative of the velocity graph. The derivative of velocity is acceleration. And they're asking the question in part 2, they're saying that, label with coordinates the points where that derivative is 0. Zero acceleration means derivative 0. And where do you get derivative 0? Maxima, minima. Now you see what I just mentioned, that wherever you can find, on the graph, the moment you're sketching all the values, answered parts of the next one, except for this inflection point I've not mentioned, because that's also a place. It's a horizontal inflection point. Just check it on the calculator. You can see it better. Can you see that there's also a horizontal tangent here, which means that those are 3 points. This point, the maxima, local maxima, the local minima. This is neither a maxima nor a minima, but you still have a zero, first derivative is zero, okay? The acceleration is zero. Let's just find that point also, okay? So it may not show up, as maxima or minima, but it'll definitely show where the derivative is zero, okay? So how do we do that? I'm going to go and find the value just by a trace, okay? So where's the trace? Here we go. Trace, graph trace, and can we just, okay, there we go, there we go, there we go. And let's just keep your eyes here, keep your eyes here, right? So somewhere on that point, okay, 4.5, 4.8, any one of those values should be fine, okay? So you're looking for the coordinates, they ask for coordinates, okay? So I'm just going to go with 4.5. All right, let me just look at the graph one more time nicely. It looks like 4.5, okay? All right, so I'm just going to write there 4.5. This is the value we're looking for. 4.5 comma negative 2.0 negative 0.209, okay? So I'm going to write that thing down here. 4.5 and negative, okay, you should see what I'm writing, right? Negative 0.209. Okay, that's good enough. Okay, so you want to be a bit more specific. You can actually, if you want to, label these points. Okay, now I'm just doing a bit extra. This is not required. A, B, C, D, E, and F, and of course G is also another point. But then you can write down for the part 2, A part 2, the answer can be written as the points B, the point D, and the point E. So even if in terms of accuracy you got it off like 4.5, 4.8, you're at least indicating to the examiner that you know which points there's zero acceleration. So you can then write down that it's B, the way you've labeled, okay? So B with coordinates, what was that? 0.524, 0.524, comma 2.4, C with coordinates, not C, sorry, D, okay, D with coordinates 2.62, comma negative 2.8, I believe, and then the point E, with coordinates 4.5, the one we just saw, 4.5, comma negative 0.209, negative 0.209. Okay, that's good enough. All right, part B. Part 1. Write down an integral expression for the distance the particle travels during the first 6 seconds of the investigation. So they already gave you the hint there, the integral, or the area under the curve, for the velocity time graph. In a velocity time graph, as I said, the derivative of the velocity is the acceleration, but the integral under the curve, the area under the curve for a velocity time graph will give you the distance. So they said, write down an integral expression for the distance of the particle, travels during the first 6 seconds of the investigation. First 6 seconds means all the way up to here, 6, right? But part of the graph is going below the x-axis, or the time axis in this case. Area cannot be negative. The safest bet is put that integral in a modular sign. Okay, so we're going to write that thing down here at the space given. So B part 1, and the part 1 is only to write the integral, just to write the integral. So it is basically, I can just write down distance. Use that word, as I've said in the other videos also. Use the words, the terms given in the question, okay? Distance, don't just write area under the curve. The distance is the integral from 0 to 6. Everything is going to be accounted for your marks, okay? Lower limit, upper limit. Okay, the expression for the velocity. What is the expression for the velocity? 2 cos t plus sine of 2t, I believe, and minus is 0.2. Let me just see whether I got that thing right, okay? So it is 2 cos t plus sine 2t minus 0.2, and do not forget the dt, okay? It's in terms of t. So put all this in a bracket and write down dt. This is it. And to be safe, as I always said, put that modulus sign. That means, you know what? You're taking care of the fact that it is not going to be negative. That's the integral expression for the distance. Now, part 2, I think, is just asking you to evaluate that. Is that right? Hence, I explained this before in the last video, I believe. In the IB vocabulary, in the IB question papers what each vocabulary means. Just like we explained the word sketch, what do they expect? So when you see the word hence, it always means, use the result from above. Use what you found above. So when it says hence, use what you have found above. What did we find? We found the integral expression. Hence, find the distance of the distance the particle travels during the first 6 seconds of the investigation. And this time, make sure that you write down the units carefully. It's meters, so the distance should be meters. You're just going to plug into the calculator so you can write down using GDC. And how did you use your GDC? That's what you're to write down. So we're going to use the GDC in a bit. So here we go. There's our calculator, and this is a graph page. Good time to see how you add a new page. Okay, so I go to Control and Dock to add a new page within the same problem. So it's going to show up as 7.2. As you can see, 7.1 is the problem number 7 or the question number 7, but it's a graph page. 7.2 is question number 7 or problem number 7, but a calculator page. And we're just going to enter the definite integral, what we have here. So I'm just going to go to the template key. Here it is. All right, the template key for the definite integral here. And strangely enough, in the TI, you know what? Here I can even enter as t. Like in the graph page, I had to enter it as x. So it's a good thing to watch in this. Okay, so the same question here, we had to write it as x. In the graph page, we could not enter it as t. Okay, so be very careful. We can't enter it as t. Wherever there's a t or any other variable, make it x. The independent variable has to be x, and the dependent variable is what you're graphing for. But here, let's do that. Okay, let's write it in terms of t, and you'll see what I mean. Okay, so this is my integral that I'm going to enter. I need to write down 0 to 6 and then 2 cos t, and I'm going to write it in terms of t just so that you see that strangely it works in the calculator page. So 0 to 6, and here let me just put that bracket. Let me put that absolute value sign first. Okay, so to find that, all right, so here you can see that modulo sign here, right? So let's do that first. Okay, there we got it, and then I can put the bracket, and so 2 cos of t. Okay, and be careful this time. Okay, there are several brackets, so be careful. I'm telling that to myself also, not just to you. And then sine of 2t, and then that bracket is there, and minus 0.2. Okay, and I hope I've got enough brackets there. And then don't forget the t here. All right, when you hit enter, what are we going to get? Syntax error. Wow, yeah, why did you get? Okay, because I put a comma. Can you see that? My God, why am I making mistakes? And you think that, yeah, it happened just like that, all right? There you go. And it gave me an expression this time, and you might be laughing, what on earth is he doing? Is he joking around? So actually, I need to change this to approximate, actually. Good, all these things are coming, So, because sometimes students come to me and say, it did. You should find a way why it's doing because of the settings, right? So let me just arrow up, bring it down, and hit enter. 7.76 meters. All right, so even with the errors, I'm glad that you all can learn by the mistakes that I'm making, because sometimes when you're solving the paper, you'll say, I entered, this is what I'm getting, but you should know that it's because of what you fed and how you set the calculator. So I'm really happy whatever's happening happens for a good reason. Okay, so I'm just going to write down using GDC. Okay, the distance, what is the language used? Distance the particle travels during the first 6 seconds. Distance the distance the particle travels in the first 6 seconds, okay, is, again, write down that integral 0 to 6, because you need to show how you got it that, right? So 0 to 6, 2 cos t plus sine of 2t minus 0.2, all right, dt. And that, according to my calculator, was 7.76. Do not forget that, the units. Okay, so that is all that we have for this particular video. If you found something useful, please don't forget to like, share, and subscribe to my channel. You'll find plenty of other videos on my channel. Do check them out. And if there's any question, any topic, any concept you want explained, do mention that in the comments, and I'll make a video for you. I'll see you all in the next video.